Good morning, GM. Welcome back to Solidity Fridays. It has been a minute. I feel like we should apologize. We have not done the stream in 3 weeks. That's partly due
I
to
apologize for nothing.
partly due to some religious holidays, partly due to some of us being stuck in a desert with no signal. But here we are. We're back. William, what is up, my dude?
Well, we can't say nothing's happened over the last few weeks for sure. In between, massive hacks, massive news, massive everything. But obviously, what we'll be focusing on today is the NFT sale that either deliberately or unintentionally created a new all-time high for gas price, which is not necessarily the kind of thing anybody wants to set a record for unless they're about to announce that they're going to make their own blockchain or something like that. Theoretically, of course. The Bored Apes or Yuga Labs sale of metaverse plots of land. It didn't, in terms of gas prices, by the way, it wasn't just like an all-time high. I think it like 5x'd the last gas all-time high. I think the last one was that that other NFT, the one attached to the TV show, Stoner Cats.
Yeah.
I think managed to hit like 2,000. But this, if I remember what I was seeing right, broke 9,000, which is obviously that's a lot of gas.
I think I saw somewhere around like 13 to 15,000 when you consider the base fee and then the tip. It was insane.
Wow. Oh, I see what you're saying. Okay, fine. All right, so you're saying the 9,000. Wow. That's interesting. You're saying even the tips ended up really spiking.
I think everything just went crazy.
Huh. Very interesting. I guess that does make sense because, usually, if I recall correctly, when things do get congested, I guess it does make sense that the tip is also going to start spiking, because even with the kind of quadratically increasing base fee, if it's quadratic, I think I can't remember if it's quadratic or not, but even with the increase in base fee from block to block due to congestion, there's still not enough space in the block. So then, even on top of the base fee, I guess it does make sense that you would kind of fall back into regular, just first price gas auction.
Yeah, I suppose. Yeah.
So do you want to introduce the Flashside contract on the back of that?
Okay, yeah. So I guess we're not here to talk about gas prices. We're here to talk about Anish's Flashside contract. So I'm still a little fuzzy on the full story of what happened with the NFT drop and the auction. Maybe Will, do you want to introduce that? I guess we've gone over it a bit, but here we are on the other side, OpenSea page.
I thought you were going to make an inevitable pun there, like here we are on the other side of the sale or something like that. So the truth is, if someone in chat could correct me if I'm wrong, because I should have researched this beforehand and completely neglected to. If I'm not mistaken, it was really just a first come, first serve public sale. Now, I think that there was, I think you needed to buy an ape. As in, Yuga also released an ERC20 token for ape and ape derivative, not ape derivative, but the official Yuga Lab ape derivative holders, I think. So I think also Kennel and Mutant. An ERC20 token, then that was the currency for the other deed sale. And I do believe that you are automatically whitelisted if you had an ape or a mutant or whatnot. And I think that actually we're going to see something like that in Anish's contract. I think you needed that in order to be able to buy. But assuming that you held one of the Yuga NFTs and that you had ape, so then you were able to first come, first serve buy a plot on their coming soon TM metaverse, and otherwise just have a cute looking NFT.
Okay.
Uh,
So yeah, so to get this cute looking NFT, you need to satisfy a few criteria, and that is to hold. Is it the Bored Ape
I
NFT?
think it's enough if you had a mutant. Taking a look at the first line here in Flashside, I'm actually going to guess that holding a kennel wasn't enough, maybe because they're not expensive enough. So it's not like, elite and special enough to hold a kennel or something like that. For those who are not very aware of the ape verse, so the original NFT collection was the Bored Apes. Then people who had a Bored Ape were airdropped the ability to mint a dog called the Bored Ape Kennel Club. And then there was the ability for them to buy, I think, something called mutagen to make a mutant ape later. So now you have the Bored Apes, the mutant apes, and the Kennel Club. And now the other side, of course. So before the actual chaos of the NFT mint started, so Anish from Paradigm, who have spent a lot of time thinking about good ways to make NFT mints, might want to spend a second on that even. Wrote Anish is kind of famous for quickly throwing together incredibly interesting repos. And he put together a repo which will allow you to basically flash into what you need to get in order to be able to claim an other side land NFT, if I am understanding correctly. We may refute our understanding of what this is doing as we look at the contract. But the basic idea is you're sitting there with no apes, you poor thing, and no ape token, and you want an other side. So then how can you do that in a way, like perform a series of transactions bundled together in a way that you end up profiting? And that is kind of the idea over here. Now, I'm not entirely certain why this is being labeled as NFT MEV. It could be because if you had not, I guess this might get into definitions of MEV. It is getting bundled together through a number of flash loans and flash swaps. I'm assuming that you would definitely want to submit this directly to a miner using something like Flashbots, because otherwise it is going to get front run to it will be instantly front run if it's profitable. So you would want to drop this in a protected transaction so that so you don't get front run if you're bundling everything together. I guess just to really Eli 5 that, there are people who can see what your transaction is going to be before your transaction happens, and who have the ability to simulate if they would make more money if they did it first. And if they would, they'll do it first instead. Oftentimes, these bots don't even know what they're doing. They just know that if they do it, they make money. So this is kind of the basis of the Ethereum is a dark forest kind of genre of literature. And over here, this is being labeled as NFT MEV in order to make a nice pretty penny off of the other side.
Awesome. Yeah. That was a really great intro into this. So here we are in the repo.
Foundry. Who would have thought it? Someone in Paradigm using Foundry.
I would never believe, hey? Never believe. Awesome. Good to see a Foundry repo. I'm keen to see more of these as we unpack more repos in the future. I saw just I think yesterday, Gaconst dropped. I think was it Anvil, which seems to be.
Oh, it's out.
Yeah,
I think
yeah,
I might have missed that.
yeah.
Ooh.
So you can move away from hard hats, simulated chain, and RPC. Anyway, let's get back to Flashside. So, so just going through this README real quick. So okay, it looks like the land had a floor of at least 2.5 ETH. So we need to in this flash loan, we need to, I think, acquire all the NFTs that sort of get you through the door, and are able to buy, and then probably enough ETH to pay the gas fees or to pay the actual price, the bid price. And then
Is this actually from Mint? This might even be after Mint, no? Atomic purchase, claim, and sale into collections floor via LooksRare. It sounds like this is even after the Mint.
it's just
I
in the
remember seeing him use the phrase long tail MEV. I think I actually may have missed that up until now. I think
right.
this is actually probably even still relevant, even after the Mint. Because
Yeah.
I think it looks like that's kind of what the LooksRare site is doing. It's buying off of LooksRare and then selling into the floor. And I'm assuming it's still profitable because of the looks and ETH kickback for buying and selling, maybe?
Well,
I'm not entirely certain how buying it and selling it on LooksRare immediately. I get, oh, maybe it's hiking up the price a little bit in between.
yeah, I think it's to detect if there's something that gets listed under floor and then sell it into the floor.
Uh,
But yeah, you're right. It's not
Interesting.
at Mint. It's like uh, I guess he's publishing the strategy as if you can now go do this sort of continuously.
ARB.
Yeah. Um,
Oh, we've got someone in chat saying that the second strategy is the purchase and claim is it's purchasing off of Bored Apes and Mutant Apes who have not yet claimed their other side. So what you're doing is you're buying a Bored Ape, using it to claim the other side that hasn't been minted yet, and then selling it back into the floor. So you're essentially break even on the Bored Ape or the Mutant Ape, but then you have the other side that you can sell, I'm assuming.
okay, nice. That makes sense. So yeah. So then we have the potential strategies: flash loan from the NFT pools, NFTX or NFT20, and then I guess from there you get your crate, whatever it is, to get that other side. Otherwise, the other strategy is to do the purchase, claim, sale into the floor on LooksRare. So that is in the secondary market. Cool. I did notice going through this is that it uses flash loans from DYDX. So that's interesting.
That's interesting.
Versus Aave. I believe that is it that DYDX doesn't charge a fee or it's a small fee?
I don't know. You're ahead of me on that.
Yeah, I'm not sure. Anyway, it is interesting. But yeah, so how do you feel? Well, should we jump in here?
Do you mind actually just first taking a look at the Foundry tunnel and the
Oh yeah, sure.
remappings? I still want to learn more about setting up good Foundry environments. Like, the little side quest.
Oh, it's not too large. Source outlook.
Oh, and there were no remappings there, were there? So I guess we're not really going to see any library use here.
Or just importing them with.
Yeah, the old way. Yeah. All right. Cool. Let's get into it. He puts test in his own folder. That's interesting. Also, with the
Yeah.
Foundry, I usually see the test go in source, which is interesting.
Source, and then it's the name of the contract .t.sol usually.
All right. So let's take a look at the NFT 20.
All right, NFT 20 first. All right, modern Solidity. Very nice. And then we have a bunch of interfaces. We've got just the standard interface for 721 NFT. We're going to be doing some transfer froms and set approval for alls. Interface for the other side land. So that is the 721, but we also have, if you're the NFT owner of or make, so the mutants or the Bored Apes, then you can claim your land. And that comes in the arguments. There are an array of UNs for
token IDs. Yeah. So it's going to be the token ID of whatever Bored Apes or Mutant Apes you've got.
Interesting that they call it alpha and beta. I don't know if this maps to Bored Apes or Mutant Apes, or is it something else?
He has it there in the net spec, actually. Bored Apes are the alpha and Mutant Apes are the beta.
One day I'll be able to read. Well, one day.
We all do it, man. Like, yeah, I wouldn't even feel like I kind of guessed alpha was Bored Ape because they came first. That there is I wonder if there's some kind of sense of humor about like the alpha and the pack from apes actually, but I beats me if it's I'm probably overthinking it a little bit there. But I mean, there's no way to see it. Like the truth is, in terms, I'm sure this is the variable names that are being used on the other side contract, but like why they wouldn't say like BA token ID and MA token ID or board token ID, mutant token ID is beyond me.
Yep. I think that would be more readable, but okay.
And there's this function claimable active.
This looks just like a view that will...
Except it doesn't have view there.
That is interesting. Yes. I guess it might run some logic to just...
Yeah, I would guess it's if the public sale is going on. And I mean, at the end of the day, what happens if the interface doesn't call it view, but it is a view in the contract? I'm still guessing. Oh, it's probably being called in the middle of a state changing function anyway. It could be it doesn't actually make a difference. Because anyway, if you call a view function in the middle of running a state changing function, you do pay for any gas that that it has to make in there. So it could be that's why there's no view there.
Okay, cool. So then I guess we get into what looks like the major contract, the Flashside NFT 20.
Using immutables for the owner and for the land contract.
So we're flash loading a board ape from NFT 20 and claim the land. That's kind of
right. For the record, NFT 20, if I understand right, I'm pretty sure it's the same thing as NFTX. So basically what you've got is you've got these pools of collections. So let's say like a pool of bored apes, a pool of CryptoPunks, and you can actually generate some kind of liquidity against them that way. But you can also kind of buy from the pool at floor at any given time. So basically there's a liquidity of bored apes there. You don't need to go P2P because there's this like pool of apes that can be bought for a homogeneous price. And then buying and depositing like your average AMM changes the price of the floor for the collection.
So there is only one NFT in the bored ape pool right now. So if you guys are interested in the strategy, I would get on that. Although you're going to be repaying it or selling
in this case. Yeah. What you might want to do is see if like NFTX or one of the other ones that does something similar has more liquidity in it. But I'm kind of guessing that this has probably dried up a bit due to other side.
Anyway, I'm not gonna... Well, let's see. Right here. Board.
Ben is now going to do MEV arbitrage on screen while live.
All right, you at least have 5 NFTs here that you could play with versus NFT 20. Sweet. So
let's we have someone in the chat whose name is actually nftmevanon, saying that NFTX is a much higher fee, like a 35% fee on Flash. So it'd be much harder to make it profitable.
That's a very high fee, but I guess the prices these things are going for, it still probably is profitable.
There's a world where that still might be able to make a profit. Yeah.
Wow.
Wacky. I think about it also to some degree. I mean, anyone who's putting in the pool there is locking up an asset worth hundreds of thousands of dollars. Like, it seems kind of niche enough that I don't know if I'd necessarily hold it against them in a pool like that. But yeah, for other less profitable NFTs, 35 cents sounds a bit high. Yeah, got our constructor over here for the address for BAYC and for ape and for other side. Does this mean it would only work for bored apes and not mutant apes? I guess you'd have to change that to mutant apes.
Yeah.
In order to be able to do it mutant apes. Also, I guess I'm kind of surprised you didn't do both. And I don't see a global for bored apes and mutant apes also.
It looks rare. It might, I don't know if it would be that the liquidity of bored apes is more. I would guess it's less actually, but
I don't know. Not an ape expert.
Oh, here we go. In this one, it uses make. So maybe it's just like giving different examples.
Yeah, Oh, there's no make pull on NFT MEV to the rescue once again.
Awesome stuff. Thanks, dude.
Yeah.
Okay, sweet. So then we have our owner set here.
Sender. I use bakes
owner.
BAC20 to spend bake balance to clawback after flash loan. Oh, okay. So we're already going to set approval for all so that after the strategy is run, you can deposit it back into the pool. And then also it makes an interface out of the land contract. Okay, cool. Execute operation. It's an interesting function name.
Yeah, I've noticed that this is, I believe, the callback from Aave. When you call Flash Loan, it goes to their lending pool and then calls back this function in your contract and runs this logic.
So you're saying it could be that's actually what it has to be named. Okay.
Yeah, I mean, I think this is DYDX Flash Loan, so I'm not sure, but I've noticed I think it is execute operation in Aave as well.
Mm-hmm. All right, so we have IDs, we have amounts, initiator, and params. Okay. Okay, so this is the claimable active. Okay, so that's what that is. You're right. It is a view function, but it checks first if if the sale is started. Okay, so it looks like we are right on that. And if it's not, then it just reverts off the bat.
Yeah. I mean, it may not just be, it may be state modifying, but for all intents and purposes, I mean, we get some sort of Boolean out of it. So we
right. Yeah, the error structure here is interesting. He's using reverts as opposed to custom errors, but he's still doing like the check and then if not, then revert.
Oh, that is interesting. So you kind of get the worst of both worlds, in my opinion.
The jump by
yeah, we've been having this debate at work actually recently, and I'm starting to lean back towards the revert pattern because like often it just kind of catches you up when you have that sort of non-intuitive like English way.
If not, then bad.
Yeah, if not, then bad, then do bad thing and stop. Versus like this sort of like a check this thing, that this thing is good.
And if it's not in your way, then keep on going.
Yeah. So I don't know. What's your take on it, Will?
I'm still leaning towards custom errors. It happens to be.
Really?
I suspect we're going to see custom errors grow a bit also. Like I know Durin, which isn't called Durin anymore. I can't remember what it's called. Nick Johnson's kind of cross-chain comms suggestion, which is getting incorporated into Ethers, kind of banks on custom errors. I get the feeling they're a bit more functional than than they are right now, and that as time goes by, they're going to take over. But that could be totally wrong. Like, I don't mind seeing reverts. Like, if someone uses reverts, I'm certainly not like, oh my gosh, it's primitive Solidity or anything like that.
Yeah.
You know?
I mean, I think that the custom errors do have slightly lower gas cost and lower contract size.
You don't need to run into the issues with like, formatting your strings to keep them short and things like that.
Yeah. Exactly. But I think for most, especially when you're on L2s or on like side chains like Polygon, I'm more interested in like code readability than those like minor changes in gas costs.
Yeah, I hear that. All right, so now it's interesting in his wording. He's actually switched to make over here on 65. He's using mutant apes there, so it seems like.
Oh, but that is beta.
Oh wait,
we are in.
Yeah. You're right. Wait, what were the arguments here again on this function? Can you show me?
Yeah,
it's IDs and amounts. No, an execute operation.
Yeah, IDs and amounts.
Doing 256 beta.
Could this be?
Maybe it is doing both of them somehow. Set up make claim array. Claim land from board apes.
So it does pass this directly into the NFT owner claim land.
Where are the IDs coming from, though? I'm a bit confused here.
So you're passing them in here. I'm not sure where you're calling this from.
Oh, okay. I get it. As in, okay, I think I figured it out. I could be wrong. Yeah. You have to, let's say you have mutant apes. So you're not flash loaning them. that's like available. But wait a second. Actually, no, wait a second. I thought I had it and I don't. Give me 1 second. No, because this isn't making a call to any of the pools to Flash Loan and Ape.
Not yet.
It's just passing in the mutant apes. Wait, so where's the Flash Loan then? So because you're triggering a Flash Loan and then it's calling this afterwards, right? You have to trigger the Flash Loan a different way, though. I don't think he's written actually triggering the Flash Loan from NFT 20. It's just the callback function, it looks like.
Here we go. This might be helpful.
Yeah, good call. But yeah, if I'm reading this right, basically he assumes that you're going to set up the Flash Loan however you want, because that's up to you, like how much you're going to ape into it. Ha 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 ha! You get it? I made an ape pun. How much you're going to ape into it and how many you're going to pull out. All he does is he writes the callback, but in the callback he'll basically just set up that if you have mutant apes, you could write that in too, so that you're claiming for both your bored apes and your mutant apes in one transaction, as opposed to splitting them out. I think it's just a kind of like a convenience helper.
Okay. Yeah, this Foundry test here is looking very juicy as well. So maybe we should get back to this. But
that makes a lot of sense.
Yeah. All right, should we carry on here?
And then it just claims the land from IDs. So like whatever you pass, whatever you're getting from the Flash Loan, and the beta, which happens to be whatever mutant apes you need to hold. So like, I wasn't paying attention during the README. I don't remember him writing instructions there, but if you were going to write instructions, I'm assuming one of them would be put in the token IDs of whatever mutant apes you're holding on line 66.
Yeah. Yes.
And that way it'll just also claim for that.
Yeah. Otherwise, this is never specified. And we just get
and it'll just pass in an empty array. Yeah.
Yeah. And then we just return true.
All right. And then we have withdraw land, which is just, it's just going to be a for loop transferring out land.
So yeah. So basically in this step, we claim the land and then that is held in this contract, right? And then here.
Which is really smart, incidentally. Because, I mean, I believe he released this before the other side sale started, but I could be wrong. But if you're thinking about something like, let's say for whatever reason, right then during the sale, you were worried about selling out if there was a cap on them, because apparently there were an astronomical amount sold. I'm wondering if there's even a cap. I guess there would have to be a cap somewhere, because if it's restricted only to holders, then it would naturally be capped by the amount that could be claimed by the amount of bored apes and mutant apes. But gas prices are astronomical. If you would have put the transfer for the land into the execute operation, it would be like, arm plus leg to transfer it all out. This way you can transfer out the land when gas is cheaper by splitting it into a different function. Very cool.
Very, very, very important.
Thoughtful.
Yeah. Transfer of an NFT is certainly not a cheap function to call. So yeah, just delaying that until gas prices are cheaper definitely makes a lot of sense.
Interesting in terms of customization, though. Obviously, reading from owner is much cheaper because you're reading from the immutable. So it's reading it from, I believe, the bytecode as opposed to the storage or memory. But it would have made sense to me here to actually have the address passed in as an argument. Yeah. In case, because you might not want it from the deploying address. You might want to send it somewhere else. But that's really just a minor aesthetic thing.
Yeah, you could definitely customize this up a bit, but I see there's no ownable import here or only owner lock on this function, so anyone can call this.
But it's only going to the good call. Yeah, good point. If you're doing it that way, you have to put owner there. You're
right. Sweet. And then we just have that on ERC721 received hook for when 721 NFT is sent to this contract. What's up?
It's interesting that he did the hex raw there. I seem to remember in Solidity 8 there's a way to do it without the raw. I think it's just to call the own function selector, isn't it? Wouldn't it be like type on ERC721 receive.selector?
Yeah, maybe, but then maybe you're just paying like a slightly higher gas cost to do that. Instead, you could just hard code it.
Oh, I hear. Yeah, I guess if we're totally optimizing, that makes sense.
Yeah.
Does that it doesn't get compiled down to that though? I would think compiling wise it would actually be the same.
I'm not sure. I've seen this around though. just kind
yeah, all right, yeah.
of like people know what this function is. It's sort of stock standard.
Cool. Should we check out the test, or do you want to go over to the LooksRare? I'm actually really keen to see the test.
Yeah, me too. Okay, so here we are in beautiful Foundry test. Yeah, well, do you want to go through like VM and test and these?
Yeah, let's do it. So Forge STD, I'm not as familiar with, but basically when you're talking about VM, the way that, okay, where do I start? Whenever you're testing a Solidity contract, basically what you're doing is you're either testing it against the state of some kind of blockchain that's running some kind of somehow. Like maybe you're forking the state off of mainnet, maybe you're running a node on a dev chain that has no meaning on your own computer or something like that. Or you can be running what we usually call an ephemeral dev chain. So something like Hard Hat Network, where it's just like this mini pseudo chain that's spun up very temporarily just to run your tests and then goes like, goes out. So what Foundry based DAppTools started this, and then Hard Hat and Foundry have really continued the tradition, each one in their own way. Foundry does it in a much more DAppTools-like way. Is there are certain hacks in the EVM that you can leverage in order to change certain states to make your tests able to test things. In plain speak, if you were writing a test, and so like let's say over here you were testing against actual state, like you're actually forking mainnet or something like that, you're going to need to fund addresses. You're going to need to pretend that you have a Bored Ape. So that involves a certain amount of work changing states that you shouldn't be allowed to change. Like technically on mainnet right now, I can't just go to DAI, knock on their door and say like, please give me million DAI now or something like that. We need the ability to do that in tests though, to fund the addresses that we're testing with. So what VM does is it gives you access to a number of functions that, so to speak, you shouldn't have in a real environment. You can change what the block number is. You can arbitrarily rewrite a contract storage. You can fund addresses with more ether than they have. You can take away their ether. Like, it's kind of like playing blockchain on God mode. So that's what VM is. I seem to remember that Forge STD exposes some helper functions on top of that also, just to make certain things easier for you. One of the things that comes up quite often in Foundry is theoretically you're a contract when you're testing in Foundry, as in you're writing all of your tests into a Solidity contract and running them. But it gets very strange when you need to manipulate other addresses. Like let's say I need to have an account that I'm testing with approve me to do something. So how do you do that? In Hard Hat, for instance, the paradigm's a bit different because they're everything you're doing from the signer. You're doing like from JavaScript outside the blockchain. So there it's a lot easier. You just switch which signer you're manipulating and you have them call approve. In Foundry, when you're doing it from the scope of a Solidity contract, it gets a bit more awkward. So back in the DAppTools days, if I'm not mistaken, you actually just had to rewrite the storage of the contract to approve yourself. I seem to remember that Brock actually had a set of helper functions for doing things like that. But like you had to get to know contract storage really well with DAppTools. And it's kind of a shame that there's such amazing helper functions in Foundry because on one hand, you kind of lose that education on the low level of what a contract looks like. But on the other hand, you can actually like sit there and code a test without having to like hack the world in order to do it. And that is what Forge STD is. At this point, Forge STD has been fully moved into the Foundry repo. It is considered to be like the Foundry testing library.
Nice. Yeah. Sweet. So I guess let's dive in.
Long-winded introduction.
We've debated, I think, before to do a Foundry focused episode, and maybe we could still do that one day.
We're kind of doing it now. It happens to be like I think getting it on the side in a lot of them is also good.
Yeah, true. But it's still, I think it's a very popular topic these days.
But Georgios, if you ever hear this and you want to come on and do Foundry, we'll let it happen. Just let us know.
Absolutely. Let's get back into the test here. So yeah, so we have our imports, the VM, the Bake 20 NFT pair. I guess that's the liquidity pool, is it?
I'm assuming, yeah.
Flashside, so that would be the contract that we're going to deploy, the Flashside NFT 20 that we were just going through, and then the land contract for the other side land NFT. Sweet. In the setup, we just set up the VM.
So yeah, this is interesting. The VM is basically a precompiled contract, so it lives at a certain address on the Foundry chain, and that's why you have to set it with this like kind of arcane address. I'm not exactly sure how it's derived, as in like all of these cheat codes kind of exist as a contract that just has superpowers in the Foundry chain.
Yeah. And then we're just sort of instantiating the rest of the contracts. And here this is in setup as well. So in Foundry, setup runs before each test.
Right, yeah.
This is almost like a before each, right? In Hard Hat, if you're familiar with that, this is the before each. I don't know if that's like a direct analogy, but that's sort of my mental model.
I think for all intents and purposes, it is. It runs before each function, if I'm not mistaken.
Sweet. So then just here at the bottom, we're instantiating or initializing this the Flashside contract as a new Flashside contract. We put in the board ape address.
Right, because you're not going to need mutant apes. You're just going to directly put in those token IDs. So at no point do you actually need the address of mutant apes, which is actually interesting.
Yeah. Okay, and then we just get the address for the board ape 20 liquidity pool and the land contract. That's pretty simple. Test claim land claimable. What's going on?
So this is just saying if claimable active works, I think.
Yeah, so this is that's the function we call claimable active to get that Boolean back from the actual contract.
And then they even mess with it. That's pretty cool. If it's not claimable, so then you make it claimable. And the way you do that is by using vm.prink. So what prink is, you'll see it puts land operator there. Operator for other side without looking, I would assume, is like the owner, like a super admin. So there's a view function there that returns the address of the operator. So you just become the operator in the test. And that's what vmprink does. The next call after vmprink makes you into whatever address you feed in. So when it says land.flip claimable state, so that will be called as the land operator.
Yeah. So that basically sets it up so that it is actually claimable, even if it isn't. Once you've checked it here, it'll then flip it to claimable. So now you can carry on.
Yeah, cool times.
Cool. And then we check the balance of the Flashside contract, so how much land it holds, and then we're storing that as balance before. Here we get to these ID arrays and amount arrays again. So this is, I guess, where we were getting tripped up a little bit. We see that they're only of length 1 each. I think that's just because we're borrowing
for the test, I'm assuming. Yeah, that would be my assumption also. Yeah, so now here we see that flash loan.
Yes. So
it sounds like you're going to need to know actually the ID. I'm not sure what amounts is. Amounts is the ERC20 token, maybe?
So with this flash loan, what you can do is you specify the ID of the NFTs, and I assume this means that there could be sort of ERC1155s, where there could be multiples of a given ID. But here, we just have this ID 731, and we're only going to borrow one of them.
So NFT MEV Anon has a good point. We saw before in the pool, there's only one ape. Another reason why it would be very wise to make this test with only one ape is in case there's not more in the pool.
Yeah, exactly. But potentially, like this should support borrowing multiple NFTs of any given ID, and you could do also multiple NFTs at once. So you could have like this ID NFT and then another one kind of all in this array, and then bunch them all together in this flash loan.
And that's why the 731 is there. I get it. Okay, yeah, all right, now it's clicking.
Yeah. And then, so this completes the loop. We pass in the address of our Flashside contract, and I think this is just the sort of the param bytes data that's not really relevant.
Yeah.
But when we pass in that address, I think what that flash loan is going to do is call this execute operation callback.
It's not relevant here, but I really would like to point out that things like bytes on Flash Loan are very underutilized, because what you have the ability to do there is basically pass data and execute it arbitrarily. Like, you could have all kinds of sorting functions, like if it's like this, do that, and like only that if this, like kind of stuff going on with the bytes. But over here, we don't need it.
Okay, so where were we? Okay, so we call the flash loan. This flash loan, I believe, will run that callback.
Execute operation, yeah.
And it will send, I think...
It should return true, no?
So... Right. Oh, right. So that's what you're doing here. So it sends the NFT to this contract. You specify, sends it to the contract. You also then would have to have approved.
Which we do in the constructor.
Yeah. So to approve that pool to take the NFTs back afterwards. So they'll transfer it back, and that approval.
Yes.
Yeah. So then what it can do, it can send the NFT here, call this, run this logic to claim your land, whatever, return true. Then it pulls its NFTs back, and you've completed the flash loan. You've paid back what you've borrowed, and you're left with the land sitting in this Flashside contract. And then we check that the balance has changed. So we check the balance of land in the contract as land balance after. And remember, we did it at the beginning as land balance before. And then this is just a Foundry way to check that land balance before
equality.
Is one less
plus
than
one.
And balance off.
Yeah.
So
it's interesting to me he didn't check the flash loan return true from execute operation.
Well, so it's the
because right, that's not going to be the end of the operation over there. Yeah. I get it.
Yeah. Right.
Cool.
That's really sick. I think that kind of
flash loans are so interesting, man.
They are. They're really cool. I mean, that kind of completes the loop on this one. We could look at, what is this test? Test claim land not claimable. Okay, so this is, I think, if we're changing it to be not claimable and then checking that it doesn't work.
Right, yeah, you can see 120, expect revert.
Yeah. Right.
I'm not sure I knew you could pass a string into that.
Good to know.
Yeah. LooksRare?
LooksRare.
LooksRare.
I'll get the test open as well. Okay, so here's the LooksRare. Do you want to get started here? Well,
let's do it. So he's just like putting a whole flattened contract in here, and types. I'm guessing. Multiple DYDX contracts, and then a minimum just to get them working. Okay, so we're gonna. I'm gonna guess that our best move here is probably gonna be to just kind of gloss here a bit. It looks like there are a bunch of custom enums and structs that are used just to make information a bit more readable. And I'm gonna guess we're gonna see probably a little bit more about this when there's a flash loan. Order types.
Look at that. I wonder what vaporized.
Yeah. What's the difference between a liquidation and a vaporization? Sounds more extreme, that's for sure.
Yeah.
Didn't merely turn it into liquid, reverted it to a gaseous state entirely.
Right. So there's our order types as well. Nice. VRS for signed order transactions on LooksRare. Should we jump down to the logic?
I'm gonna guess. I think we're pretty much there anyway. But yeah, we're gonna have the bare bones interfaces that we're gonna need to interact with DOIDX and LooksRare also. I'm actually kind of surprised that we pulled that off in under 150 lines of code even. Like, I actually find that fairly impressive. I may even use this as a reference if I ever need to interact with LooksRare, to be honest. Sometimes it's really like the little breadcrumbs like that makes such a difference in coding. Just knowing that I don't have to memorize or figure out how to interact with LooksRare. I know somewhere where it was done very succinctly. Like, I find it really speeds up my dev process.
For sure, yeah. I mean, LooksRare should also have a library that you could import, and I think that should make life easier.
It should make life easier, but it'll probably also be a lot bigger.
Yeah, true.
So yeah, so over here we're going to buy mutant apes from LooksRare via a DYDX flash loan, claim the land, and sell it back into the floor. All right. So we've got WETH because I'm assuming that's the most common. Like, I'm assuming most things are denominated in WETH. They don't use direct ether on LooksRare, or maybe it's for DYDX. I'm not sure. I guess we'll figure it out. We've got the owner again is an immutable, land is an immutable, solo margin. Oh, so I guess that's where the flash loan comes from in DYDX, and the LooksRare exchange. All of those are going to be immutables. Makes them cheaper to call. All of those get passed in the constructor, and that's like just the first chunk of the constructor logic. Max approval. Oh, we're going to need for WETH.
That's interesting that they store that. I mean, you can just...
Yeah, isn't there type type UN256.max or something like that?
Yeah. I think, or you could do UN256 -1 within the brackets.
It's interesting also that actually compiles. Like, that can be evaluated. Because theoretically, once you do 2 to the 256, that's over the max, and you're in Solidity 8. So, like, you would technically have an overflow. Yeah. So it is interesting that that evaluates, but I've seen that there's other languages where it works like that also. Like, it doesn't evaluate until you've made it through all the operations in the statement, or something like that.
Yeah. So yeah, this is, I think, this is one way to do it. Succinct way.
I don't know if I knew that way.
But yeah.
Huh.
Please. Anyway.
Right, and then we just approve DYDX and LooksRare.
Yep. And we have that again set approval for all on the transfer manager.
From Meg.
LooksRare. Give LooksRare exchange. Yeah. Okay.
Why is it called transfer manager? Mutant apes in multiple contracts? I guess so. That's a bit interesting. Might be worth looking at some point. Wait, oh wait, no, something's funky here. Could you go back up to the constructor if you don't mind?
Sure, yeah.
Thanks. So you're calling the mutant ape contract, you're setting approval for all that that should be LooksRare, right? So I guess LooksRare has something called a make transfer manager, or is that just what we're calling it here?
Well, I
guess it's a different contract than the exchange.
Where are we getting that from?
Yeah, good call.
Here we go. So we're just passing it in. I think it might just be
is
like...
there that spec on it above?
No.
No. All right, fine. Yeah, so I'm assuming that's just a contract LooksRare has.
Let's see.
Oh, LooksRare has independent transfer managers per NFT collection type. Thank you once again, NFT MEV Anon. Appreciated.
There we go. So in the tests, that's the address that we're passing in the make transfer manager, which lines up with what NFT MEV Anon is saying.
Mm-hmm.
Yes.
Cool.
Initiate flash loan.
All right. So yeah, and this is I'm starting to really like this style of passing in enums.
Yeah. It's very succinct, and you can just squeeze in a ton of call data.
Mm-hmm. And in a way, it also just makes things easier. You know what I mean?
Readable.
Yeah, that's what I meant.
Yeah.
So there's the type for the purchase order and for the sale order. So that initiates flash loan execution, call function callback, purchase order to match against and buy, and then sale order to match against sell. Interesting. All right. So first we make sure that land is claimable, and if not, we revert the whole thing before we get started. Action args operation, new actions dot action args. Find actions.action args. So operation 0 is going to be withdraw, account ID 0, types asset amount, sign false. It's not a signed integer, I guess. Denomination and way, reference delta, and purchase order dot price. I'm assuming purchase order. I'm not good enough to figure this all out, like right off the cuff. But it's going to be the parameters for borrowing to buy the mutant ape. And then the next one, the operations 1. Okay, yeah. Okay, so I'm starting to get it from the action types a bit. On 192, we've got actions, action type, withdraw. So that's going to be pulling money out of DYDX, at least I think so. Then on 210, you've got a call as the next thing that you're going to do. I'm assuming it's going to be to buy the mutant ape, but you're kind of telling DYDX to do it. Oh, no, I don't think that's strictly,
No,
I don't think that's correct.
I think you're batching these into an operations array.
Mm-hmm.
And then you're...
Yeah.
Oh, okay. You're passing that to solo margin.operate. Yeah. So yeah, I guess you do pass that to...
I'm assuming it's telling DYDX like what you want to do with this.
Yeah. Which is interesting. It's a whole different way to do it.
It's interesting to see. Instead of it being kind of like on your contract where you're figuring out what to do, it's kind of on theirs. And they just kind of execute it with like a multi-call or something like that.
Yeah.
So that executes the flash loan. All right. And then I'm assuming that's going to have a callback into a different function, which is going to be call function. Call function, I'm assuming, is their callback.
Yeah. Okay, so this is where we do most of our chunky logic, right?
I'm guessing.
And this was specifying just sort of like the assets we're borrowing, and then what we...
Oh, yeah, you're right. Yeah, I assumed that like some of the LooksRare interaction was there, but you're right. It's all in call function, it looks like.
Yeah, so there we go. Okay. Here we have withdraw with from DYDX. Then we get DYDX to execute that call function below. And then we deposit with back to DYDX. I think that we approve it to take, we approve DYDX, solo margin, to take it so they can just, in that sort of operation, they can just pull it back out.
Mm-hmm. Yeah. Got it.
Awesome. So yeah, this is the sort of the middle part once we have the funds.
So we have here address sender, account info, bytes memory data. So then we decode order types. Order type dot make order memory purchase ask. Make order memory seal bid API dot decode data. Order type static. Okay, I think I need to know the flash loan a bit better to figure out the decoding going on over there. But you're like decoding it by putting data with those. Almost looks like it's setting up a call.
Yeah, decode. So decode variables passed in data. So so yeah, that's where we can pass in probably some complex specification of like how we're going to purchase and make bids.
Or even a function. I'm wondering if it's like a function signature. No, we need encode packed for that, I think.
So yeah, it'll be a ton of data.
Be packed?
And then we decode it in this order.
Yeah, NFT MEV saying also that it's like return data for I think we're going to see it's going to be for making a call. later, so that like you pass the data to DYDX and then DYDX, or no, you go from Flashside to DYDX. DYDX is sending you back the data so that you're able to decode that and make a call with it back on Flashside, I think.
So I think it's coming from here, actually. So when you call initiate flash loan,
you're already passing it in.
Yeah, you pass it in, and then you put it here somewhere as data. Yeah, there we go. Data ABI encode.
ABI encode, right? And then you're decoding it out right here. Yeah.
Yeah, nice.
NFT MEV agrees. Just put it in chat right now. So
noise. Sweet. So then we'll go back here. We just sort of extract that out again.
Yeah. Order types: take order, taker order. Is order ask false? Taker address this. Price, token ID, min percentage to ask. Params, fine. And that is the purchase bid, which is now sent into LooksRare, which has one of these amazing function names: match ask with taker bid using ETH and WETH. So they could take ETH, it sounds like. I'm assuming you can't flash loan the ETH, though. The purchase bid and purchase ask. Where was the purchase ask, actually? That argument on 274. Where's it coming from? Oh, it's passed in. There we go. It's right there on 257 also.
Sell bid and the purchase ask.
Yeah, okay, cool.
Because you're gonna buy it, and then you're gonna immediately like sort of put it up for sale at the ask. At this, yeah. So this is your buy, and this is your sell.
Yeah.
And thinking about the ETH here, that it would accept ETH, but you can't flash loan ETH, is because I think the contract, like DYDX, needs to pull the money back out from you.
Right.
It can't do that with ETH. It can do that with WETH, because you approve them to do that.
Approve it.
ERC20. Yeah.
All right, cool. So this time we're doing the Bored Apes just get written in, and that's the alpha over there, 278. The Mutant Apes also, it looks like oh, right, there's only a bid here for one, it looks like. So we pull that in, and then, okay, and purchase ask.token ID becomes you just put right into beta 0. Yeah, you put in as the first element in beta, and then you claim land with it, alpha beta. Then you make a sell bid. And match bid with taker ask. And then whatever WETH and ETH you've got, you pay back the flash loan with. That's it. Oh, because if you have any Ether, maybe you're even okay. LooksRare is probably doing Ether. That's why we need the WETH address, because whatever Ether you're getting, you're going to need to turn back into WETH so that it can be pulled out in order to repay the flash loan.
Yeah, makes sense. And yeah, so you see match bid with taker ask. This is doing, I guess, a market sell. So you just are looking at that, essentially an order book, and finding some ask price and selling it at that ask price. So you immediately pull the ETH out at that sale. You're not waiting for someone to like match up.
Very cool. And then we have that split out into withdraw land also.
Yeah.
Oh, and here also, because it's more likely here that there could be, oh, well, interesting. I wonder what happens if you end up selling for more than you thought you would. Is that going to end up, like, what happens if you pay back too much to a flash loan? Does it only take what it's supposed to take and give you back the rest? I wonder. Oh, probably. Almost certainly, come to think of it, because you're not actually sending it to DYDX. DYDX is just approved to take whatever it wants.
Yeah.
So I'm assuming it's just coded in that it only takes whatever. So, okay, since you could get lucky and end up getting more than you think you would, there is also still going to be a withdraw balance and a withdraw balance WETH over here, where it sends out any Ether or any excess WETH back to you. Excess Ether, it'd probably be a bit of a weird edge case for there to be excess Ether.
Well, you're swapping the entire balance of ETH that you have here into WETH, so they shouldn't.
Right. The only way I can think of is there's a decent chance you top off the contract with some ether beforehand, just in case you don't get as much as you think you would get from selling your mutant ape. That way you still have enough to pay back the flash loan. Yeah. So you might just want to top off some ether in the contract beforehand. So right. If you top off the contract with some ether and then you're unable to make this whole kind of like flash, so then you'll just have ether sitting in the contract. So you might want to pull it back out. That's the only scenario I can think of where you'd be pulling ether out.
Well, it would be turned into WETH. Because
it wouldn't if the whole thing fails, though. Like, let's say you're unable to do anything. Right. So you've topped off the contract first, but then you're not able to do anything.
Yes, yeah, okay. So you're correct. So if we fail, if the transaction fails and everything reverts, then we don't ever run this convert to WETH step.
Right. Right. So if you topped it off beforehand, which sounds like a very reasonable idea in my humble opinion.
Yeah.
Then you probably want that withdraw. So that would be withdraw balance. That pulls out your whatever ether is in the contract, and withdraw balance WETH will take whatever WETH is left over in the contract. And we have the on ERC 721 received, and you can see even here he puts a received payable there, which makes sense also in case you just want to send the contract some ether to top it off before you do your thing.
Yep.
Very cool.
That wraps it up, hey? And look at that.
Yeah, don't it?
Be on time for us.
We actually did it, man. Yeah. So major kudos to Anish. This is like super, super cool to read. Really awesome contracts here. And yeah, special thanks to NFT MEV in the chat. Also, thank you very much for your help with and looking through this. And yeah, awesome.
Awesome. Thanks, guys. Me, Rory, and will catch you next Friday, unless one of us is.
We hope it's next Friday. Yeah.